Hey guys, so we have this, we're looking at this whiteboard right here, and I see a lot of sevens, but I wonder, is there anything else you notice about what's happening here? Okay, so the answer that first popped out in my mind, which might not necessarily be yours, is that we're adding a group of 7 each time, okay? So this one right here, we just have 1 7, okay? So let's write that in unit form. Right, we have 1 7. Right, we just have one group of 7 here. How many 7s do we have here? Good, 2 7s. I'm sorry guys, that was ugly. Here, good. We go up by 1 each time, so now we have 4. Now it's your job, type in the short answer. What does our unit form look like in this last group? So yeah, our unit form for this last group, 5 7s, because we have 5 groups of 7. All right. Now, we also had another form, right? Do you remember what that form was called? Yeah, fact form, okay? So it would be what multiplication fact goes with the picture. So in this case, nice and simple, 1 7 is one group of 7, okay? 2 7s, 2 groups of 7. What would be the fact form for this next group? Good. 3 groups of 7, or 3 times 7. Now we have 4 times 7. And what's the last one? Pick the right answer. Exactly. 5 times 7. Good. Awesome. So yeah, this kind of reminds me yesterday when we were doing that multiplication chart, right? And we would do 1 times 7, put in the answer, then 2 times 7, put in the answer, and we would see each time we would add. What number would we add to each of these red numbers? How would we get these? By adding 7. Exactly. 28 and 35. Now, other than just one group of 7, or maybe 2 groups of 7, 5 groups of 7 is probably the easiest one for us to work with, right? Because we get to skip count by 5s. So we are going to use 5 groups of 7 to solve some more difficult problems with 7. All right, so here I made it a little easier for us to look at. We have 5 7s, 5 groups of 7. And remind me really quick, what's our product when we have 5 times 7? Yes, 35. Now, again, we said that was a nice and easy fact because we get to skip count by 5s, right? Even though we have 5 groups of 7 here. We also know that if we count by 5 7 times, we will get the same answer, right? We go 5, 10, 15, 20, 25, 30, 35. That's counting by 5 7 times. We get the same answer as counting by 7 5 times. All right. Now, let's say that we had this problem. Here, let me use my other marker. Six groups of 7. How could we solve this problem? So yeah, there's a few ways, right? Like I could, because we already have 5 7s, just add another 7 to here. Or I can just take this number, instead of having to draw this out, and I can think, if we have 5 groups of 7, now we have 6 groups of 7. That's the same as adding how many more? 1 more, right? That'd be the same as doing this. So, what number should we add to 35? Because right? This box here is 35. 1 more group of 7. So the box here shows 5 groups of 7 gives us 35. 1 more group of 7 gives us 6 groups of 7. So we just add 35 plus 7. What is 35 plus 7? Yeah, exactly. 42. Good job. Now let's see if you can figure out what we would do if we had a slightly more difficult problem. Or you know what? That's actually where we're going to stop for now. Okay? So that's what you are going to work on in this problem set today. We are using the commutative property still, right? This one right here. And we can also use skip counting and equal groups to help us. But we're also focusing on using facts that we already know to help us solve harder facts, right? Use the facts that we already know that are simple or easy to solve ones that are difficult. All right? You may exit out of this Edpuzzle. Ms. Hazel will close breakout rooms soon, and you will continue with what is next. All right? Good work.